Okay, the first problem on the quiz is a polynomial division problem. We learned synthetic division this chapter, so we'll go ahead and use that. We're dividing by x minus 1. Recall that the number that goes in the box over here is the opposite sign of that number. 1 minus 1 makes 0. Remember, synthetic division only works if it is 1x plus or minus something, so we can use it. It'll be that way on the quiz. We're dividing into 2x cubed minus 3x squared plus 4x minus 1. Every power of x from the highest power 3 down to the constant is accounted for, so we have no zero terms. So 2, negative 3, positive 4, negative 1 are the coefficients. If there was a power missing, for example, it was 2x cubed plus 4x minus 1, this will be a 0. You do have to put the 0 there, and that may happen on the quiz. Once you get the synthetic division set up properly, then it's just a matter of applying the synthetic division technique. The first step is to bring the first number straight down as is, and then we get every next number up here by multiplying the number we have down here times the number up in the bracket. So 2 times 1 is 2. We get each next number down by adding. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. 4 plus negative 1 is 3. 1 times 3 is 3. Negative 1 plus 3 is 2. And the answer, without powers of x on it, is there with a remainder of 2. And the way we need to write our answer then is as a polynomial structure. Whatever the power of the original problem is, this is one lesser power. So x cubed in the original problem, this will be 2x squared. That'll be minus 1x. That'll be plus 3. And then there's a remainder of positive 2, so I put a plus because it's positive, and I put my remainder over the divisor. Do make sure that the first object can be positive, no sign necessary. Every other thing after that has to have a sign. Minus, plus, plus. If you leave out signs, you're going to lose credit. You know, I'm expecting to see this answer on your paper, so as far as partial credit is concerned, I'd have to look and see what your synthetic division look like. If you got some wrong numbers in here, maybe it costs some partial credit. Not being able to go from here to there is going to cost you about probably 3 or 4 points there, so make sure you're able to do that. Number 2, verify that x plus 2 is a factor of p of x equals x cubed plus 5x squared plus 5x minus 2. Right? P of x is the product of the binomial and its reduced polynomial, so basically it's a factoring problem. It does say to verify. That's just a matter of doing synthetic division again. So if this is a factor, we can divide by it. Again, using synthetic division, x plus 2 is the divisor, minus 2 is the opposite sign of positive 2, so we're going to put negative 2 up in the bracket. We have 1, 5, 5, negative 2 is the coefficients. Again, no power of x is missing, so there's no zeros necessary. Perform synthetic division as we did in the first problem. Bring the 1 straight down. Negative 2 times 1 is negative 2. 5 minus 2 is 3. Negative 2 times 3 is negative 6. 5 minus 6 is negative 1. Negative 2 times negative 1 is positive 2. Negative 2 plus 2 is 0. Remainder of 0 verifies. So verification is synthetic division with remainder 0. Once we see that the remainder is 0, the reduced polynomial is 1x squared plus 3x minus 1. They want us to write p of x, which is this expression, as the product of the binomial, which is x plus 2, and the reduced polynomial q of x, which is this guy here, x squared plus 3x minus 1. So p of x equals that. So you verify that it's a factor, and if it is a factor, x plus 2 is in the factored form, and what's left over when we divide by it is the other factor. Number 3, find the 3 real zeros of p of x equals x cubed plus 3x squared minus 10x. To find real zeros really depends on the problem. X to the third power, you can notice on this one, if I take an x out, that gets me to a factored form of that, x squared plus 3x minus 10 being multiplied by the x. I noticed x being a common factor there. The problem on the test that resembles this would be a problem where factoring would be the easiest way to do it. So taking out the common factor of x drops it down to a quadratic, and then the quadratic even factors we can see that positive 5 and negative 2 multiply to make negative 10, they had to make positive 3. So x plus 5 times x minus 2. So p of x can be rewritten in factored form as x times x plus 5 times x minus 2. Once I get it factored, the job is to find the 3 real zeros. Each factor represents a possible answer as long as there is a variable in the factor. And as you can see, x is a variable, x plus 5, x is a variable, x minus 2, x is a variable. All three factors contain x. So to find the zeros, I simply set each of those factors equal to 0. So x equals 0, x plus 5 equals 0, x minus 2 equals 0. And if I solve each of those individually, x equals 0 is already done. Move the 5 over, becomes negative 5. So 0 minus 5 is negative 5. Move the 2 over, becomes positive 2. 0 plus 2 is positive 2. So the 3 real zeros are 0, negative 5, and 2. Again, that problem there specifically, number 3 on the quiz, you should expect factoring to be the technique you want to use. It should work out similarly to this. Number 4, determine the x-intercepts of p of x equals x minus 5 squared times x plus 1 cubed, and use the even and odd powers of x minus c theorem to determine whether the graph of p crosses the x-axis or intersects but does not cross. This is probably the easiest problem on the test. You can see here that x minus 5 is a factor. It's being raised to the second power. That just tells me that x equals 5 is a root. Okay, so it says determine the x-intercepts, also known as roots or solutions. 5 minus 5 is 0, so 5 is the answer. And the fact that the power is even tells me it's a touch and turn. And then the other factors, x plus 1 is being raised to the third power. Negative 1 plus 1 is 0, so x equals negative 1. This is an odd power, so it's going to cross. There really is no work to show on that one, so it's going to be, there's 2 answers, 5 points per answer. I suppose maybe 2 points for the root, 3 points for the nature of the root kind of thing, so kind of, hopefully you don't miss it. But again, partial credits, there's no work to really be shown there because it's just that easy a problem. So get the answer. Even means touch and turn, odd means cross, and that's all there is to that. Number 5. A company constructs boxes from rectangular pieces of cardboard that measure 12 inches by 18 inches. An open box is formed by cutting squares that measure x inches by x inches from each corner of the cardboard and folding up the sides as shown in the following figure. They want the volume of the box and they want to know the value of x that maximizes the volume of the box. And this is a simple box. It'll be similar to this on the test. The base of the box would be right here. And each of these, this one and this one and this one and this one, would simply be the sides of the box with these pieces being cut out. So those pieces of cardboard are going to be discarded. What we're looking for to find volume is length, width, and height. The height would be how high the walls are, so the check marks represent the walls. If I fold these sides up, that's how high each of the sides is going to be. So x is the height of each of the of the whole box. Length and width are a factor of these numbers and how much we're taking away. So 12 and 18, those two numbers establish how long the cardboard was, how wide the cardboard was. This right here is the length of the base. And we have 18 inches all the way across. We're deducting x and x more here together. So 18 minus 2x is what we got for a length. As far as width is concerned, 12 is the width of the cardboard from here to here. We're taking x off of this side and x off of this side, so that's a total of 12 minus 2x for that. So length, width, and height, they're very easy to determine. Once we get those three expressions, volume is simply length times width times height. So volume becomes that. I like to put my monomial in front, so length times width times height. And as far as multiplying this out, I would expect it to be multiplied out. 18 times 12 is, let's see, 6 carry the 1, 216. And then 18 times negative 2x is negative 36x. Negative 2x times 12 is negative 24x. negative 2x times negative 2x is positive 4x squared. And then if I just distribute the x through, combining like terms as I go, and I like to go to the highest power first. So x times 4x squared is 4x cubed. Negative 60x times x is negative 60x squared. 216 times x is 216x. That represents my volume of this box. Now, for part B, that was part A obviously. Part B, they want to know the value of x to the nearest hundredth of an inch. That's 2 decimal places. Nearest hundredth of an inch. The x value that maximizes the volume of the box. So, in order to do this problem, I have to establish a domain. And what I want to do is make sure that length, width, and height are all positive. Height, x greater than 0, that's pretty obvious. The one that's more challenging is getting the other x. The x is less than a number. If I do 18 minus 2x is greater than 0, that means negative 2x is greater than negative 18, which means x is less than 9. If I do the same thing to 12 minus 2x, make this a 12 instead of an 18, that makes this a 12 instead of an 18, which makes this a 6 instead of a 9. X is less than 6 and x is less than 9, we take the smaller one. So x less than 6, x greater than 0, x has to be between 0 and 6. What I do then is I simply go to y equals, and I type in my volume formula, which is 4x cubed. Make sure that when you hit the caret 3, it puts you up there, you've got to press the right to get back down. Minus 60x squared plus 216x. As far as my window is concerned, I'm going to go from 0 to 6. My magic window where x is allowed to be, that can actually create a box. If x is bigger than 6, such as 7, let's say, 12 minus 14 makes negative 2. That's not a possible box. So again, x has to be between 0 and 6 in order to be able to construct a box. As far as y is concerned, I always start at 0 on the bottom. As far as the top, whatever 12 times 18 is, which was 216, that's a pretty safe bet to be high enough. If it isn't, we can always make it bigger. That's a lot of numbers there, so maybe I go up by 20s instead of 1s. Hit graph and see what happens. Hopefully we see the top of the graph. Ooh, got off the screen just a little bit. Again, that can happen sometimes, so if you're, again, that's my estimating value. I just multiply those together, whatever I get, that's where I put my top. If it's not big enough, I can't see the top, I'm just going to extend it up a little bit. So obviously 216 wasn't quite big enough. Maybe I can go up to 300. That definitely is big enough. As long as you see the top of the graph, it's a good graph. So what I can do just by an eye inspection here, I put x at a 1 scale, that's 1, 2, 3, 4, 5, 6. I can see the answer is a little bit bigger than 2, somewhere in this 2.2, 2.3 range probably. So once I know the answer is around 2.2, 2.3, I go second calc. I choose maximum because I'm trying to find the maximum. I just need to pick something left of the answer. So I know that 1 is left of 2.2 or 2.3. I know 4 is to the right of 2.2 or 2.3. The lines that are drawn, the maximum should be in between them somewhere. And 1 and 4 were my boundaries. As long as I pick anything between 1 and 4, such as 2, it will pinpoint the right answer. 2.35, it said to the nearest hundredth. That's 2 decimal places. So x equals 2.35 inches is going to maximize the volume of the box. The maximum volume of the box is 228.16. It didn't ask for that though. It says find what x should be, so I found out what x should be. Number 6, use the rational zero theorem to list the possible rational zeros. They're not asking for the answers, they're asking for the list of possible answers. And if you recall, the rational zero theorem requires that the polynomial be put in descending order. The highest power term and the constant are the two numbers that matter to us. And the possible rational roots are simply going to be all the factors of the constant on top so every number that divides 12, 1, 2, 3, 4, 6, and 12, plus or minus every one of them. And on the bottom we simply put the factors of the first coefficient, the lead coefficient 2, that would be 1 and 2. Don't worry about the pluses and minuses there because we've already got plus or minus taken care of with the top. And all the possible rational roots are every one of the purple numbers divided by every one of the red numbers. And if we get a reduced version of the same thing, we don't write it twice. So the possible rational root list on this one is simply going to be all these numbers divided by 1, so all those numbers. And then all those numbers divided by 2. 1 over 2 is different. We haven't gotten a half yet, so plus or minus a half. 2 over 2 is 1 we've already got. 3 over 2 we haven't gotten yet, so plus or minus 3 over 2. 4 over 2 is 2. 6 over 2 is 3. 12 over 2 is 6. Every other number over 2 has been taken care of. So that right there is the list of every rational number that could possibly be a correct answer to that problem. That's all they're asking for there. Give me a list. Don't solve it. Don't do anything beyond that. Stop there. Number 7, use Descartes' rule of signs. Okay, just as I showed you in class, when I get these directions, I immediately go to P of x and P of negative x. P of x, as you can see, is 6x to the fourth minus 3x cubed plus 2x squared minus 4x plus 7. P of negative x simply takes all the odd-powered terms, which would be these two. Fourth is even, second is even, 0 is even, x to the 0. 3 and 1 are both odd. The odd-powered terms change signs, the even-powered terms don't. So 6x to the 4 stays positive, 3x cubed becomes positive. 2x squared stays positive, negative 4x becomes positive. 7 stays positive. Okay, so these two guys change to positives, the other three stayed positive because they're all even powers. So P of x, P of negative x. P of x tells us everything we need to know about the positive solutions. We're looking for sign variations from the first to the second and so on. So we're positive, it switches to negative, that's a variation in sign. It switches back to positive, variation in sign. Switches back to negative, variation in sign. Switches back to positive, variation in sign. So there's a total of 4 variations in sign. So for positive solutions, there are either 4 or 2 or 0 positive solutions to this problem. Looking at variations in sign on the bottom one, P of negative x, positive stays positive, stays positive, stays positive, stays positive. It never changes sign. So the negative solutions for this one would be 0. All right. P of x tells us everything we need to know about positive. P of negative x tells us everything we need to know about negative, which is pretty straightforward, positive, negative. And again, any answer you get for variations in sign, keep deducting 2 until you get down to 0 or 1. If there were 3 variations in sign, 3 or 1 would be the answer. If there were 8, 6, 4, 2, or 0, so just whatever the number is, keep counting down until you get down to 1 or 0. If you start at 0 or 1, that's all you have. Number 8, find the zeros of P of x equals all that. If 0 is a multiple 0, state its multiplicity. This time it's a cubic function. It's not as easily factored as number 3 was, so this would be one where I'd want to use my techniques that we learned in chapter 3.3, I believe. Yep, 3.3. So, first thing I do is I do Descartes' rule of signs to determine if I can throw out some values. So I know P of x equals that. P of negative x is negative x cubed minus 2x squared plus 4x plus 8. Odd power changed, even power stayed the same. Odd power changed, even power changed, stayed the same. So looking at positive solutions and negative solutions, I know that there's 1 variation in sign, 2 variations in sign, so there's either 2 or 0 positive solutions. For negative, negative stays negative, switches to positive, stays positive. There's exactly 1 negative solution. Okay, so I know there's 1 negative, I know there's maybe 2, maybe 0 positives. So I'd probably start with my negative solutions personally if I was making my list. So possible rational roots here. I'm going to do plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Putting plus or minus because there are possibilities of both types. All that will be divided by 1, so that's my whole list. That's every number that could possibly be the right answer to this problem. Then I go to my calculator. I enter my function, x cubed minus 2x squared minus 4x plus 8. I go to my table. Oops. Hang on. Did what I keep on telling you guys not to do. So let's try this again. X cubed, push to the right to get out of the power level, minus 2x squared minus 4x plus 8. I'm going to go to my table, and I had, well, right there, negative 2 is already there. But if I had done negative 1, negative 2, negative 4, negative 8. Again, I know there's one negative solution. If I can find that one negative solution, which is negative 2, I'm good to go. So, negative 2 is a solution, which tells me if I did a synthetic division with negative 2. Now keep in mind here, I'm not dividing by x plus 2, or I'm not dividing by x minus 2, I'm just seeing if negative 2 works. So anytime you have an answer, whatever the answer is goes there, no sign change necessary. And I'm not working with p of negative x anymore. You might even scribble this out. Once you get the information you need from it, which was this, once you get all this information, maybe scribble out p of negative x off your paper so you're not looking at it anymore and thinking, hey, maybe that's important still. That's all I needed that for. Once I get that information, make it disappear. 1x cubed minus 2x squared minus 4x plus 8. Bring the 1 down. Negative 2 times 1 is negative 2. Negative 2 plus 2 is negative 4. Negative 2 times negative 4 is positive 8. Negative 4 plus 8 is positive 4. Negative 2 times 4 is negative 8. Remainder 0. It has to be a remainder 0, so if it doesn't equal 0, that means you did something wrong. First place I look is to make sure I put the correct number there. Again, whatever number I said was the answer, which was negative 2, that's what goes there. The other thing that people do wrong is, for some reason, they'll like maybe modify this number, or maybe do something weird, like maybe add those instead of subtract and that kind of thing. So just look at your math, make sure you do everything properly. The leftover reduced polynomial is x squared minus 4x plus 4. We want that to equal 0, because again, that's what we're trying to find here, are the zeros. So if I go to solve this, I would factor to x minus 2 times x minus 2, which gets me x equals 2 and 2. So my answers are negative 2, positive 2, and positive 2. And the part about its multiplicity means that if it happens more than once, we put multiplicity of that number. So I would put x equals negative 2, comma 2, multiplicity 2. Negative 2 happens once, positive 2 happens twice. The reason multiplicity is important when we go back to that even and odd powers of x minus c theorem. If I was trying to graph this, it would cross at negative 2 and touch and turn at positive 2. Some of you might be thinking, why don't I just put all these numbers in my calculator and I can see where it equals 0, which is all well and good, but notice 0, 0, you only get 2 answers out of your list of 8 possible answers. We know there's 3 answers. You know, we might not realize there's 2 2's there. So getting down to the quadratic and being able to factor it or even use a quadratic formula will allow you. Plus, if the other 2 answers weren't rational, 3 plus or minus the square root of 7 over 2, something like that, then you'd want to use the quadratic formula to get those answers. So again, reducing down to quadratic is important, so be able to do that. Number 9, a propane tank has the shape of a circular cylinder with a hemisphere at each end. The cylinder is 8 feet long, the volume of the tank is 24 cubic feet. Find the nearest thousandth of a foot, the length of the radius x. This problem just goes back to the whole, you need to remember everything you've ever learned about math to do this class. And what we're dealing with here is volume of a tank. What I know is the length of the cylinder is 8 feet from the end of the hemisphere to the end of the hemisphere. Then you got this hemisphere on either end. 2 hemispheres together make a whole sphere. So what we're looking at is the volume of a cylinder, which is just going to be the area of the base, which is pi x squared in this case, because the base is this circle. Radius is x, so pi x squared is the area of the circle, multiplied by the length or the height of the cylinder. If you imagine this cylinder here, circle to circle is 8 feet apart. So the volume of the cylinder altogether is 8 pi x squared or cubic feet. The volume of the sphere, because again it is a whole sphere, you have half a sphere here, half a sphere there, stick them together, you get a whole sphere, is just 4/3 pi times the radius squared. The radius is still x, or sorry, cubed. 4/3 pi x cubed. Okay, that's just the formula for the volume of the sphere. 4/3 pi times the radius cubed. The radius in this case is x, so 4/3 pi x cubed. So the volume of the whole tank is simply the cylinder added to the sphere. So cylinder, half a sphere makes a whole sphere. Altogether, that's the volume of this tank. So the volume of the tank is equal to 8 pi x squared plus 4/3 pi x cubed. Next, they tell me the volume of the tank is 24 pi cubic feet. The volume right there is 24 pi cubic feet. That equals 8 pi x squared plus 4/3 pi x cubed. So just like that, I get myself a polynomial function that can be solved. My job is to find out what x equals that makes this work. Okay, we'll do that in a minute. Before I do that, I'm going to simplify my problem a little bit, because I noticed that this has a pi, and this has a pi, and this has a pi, which means division by pi is going to make the pi's go away from all the terms. I also notice this has a 4/3. I might not want to work with fractions, so if I multiply the entire equation times 3, I'm going to get 72 equals 24x squared plus 4x cubed. One final thing I noticed, everything divides by 4. 18 equals 6x squared plus x cubed. Be as creative as you want, but you can just keep going through this. Our job is to determine what x equals, and the easiest way to find out what x equals is get the entire equation equals 0. So x cubed plus 6x squared minus 18 equals 0 is the simplest this equation can be. And once I get it equal to 0, I go back to my calculator, and I go back to y equals, and I enter the equation in x cubed, push to the right to get out of the power level, plus 6x squared minus 18. I have no idea what this radius is supposed to be. I know it's bigger than 0, so for my window, maybe that's fine, 0 to 6. I'm looking for it crossing the x-axis, so this is my function. X-axis here is going to be negative. At some point it's going to cross the x-axis. Where it happens is where we care about it. So I'm going to go from negative 10 to 10. Just so my x-axis is in the middle. Scaling of that really isn't important. So I'm assuming the answer is between 0 and 6. Hit graph. And we can see very clearly it's actually between 1 and 2. If I wanted to get a closer view of that, I can go from 1 to 2 at a 0.1 scale, hit graph again, and then I can count by 0.1s, 2, or 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. So it's between 1.5 and 1.6. It doesn't really matter how close you zoom in. I mean, again, I could have gone back to what we started off with, 0 to 6, that was fine also. All I care about is where does it cross the x-axis. I can very clearly see with my eyes it crosses between 1 and 2. So I go to my calculate function, second calc, right above trace, and I'm trying to find the zeros, so choose number 2. Left bound, right bound guess. Every time you do one of these maximums, minimums, zeros, whatever, left bound, right bound guess. The answer is where you want it to be. Left bound is left of that, so 1. Right bound is right of that, 2. Again, as long as those lines are on either side of what you're looking for, which is where it crosses the x-axis, and as long as your guess is between those two numbers you just picked, 1 and 2, 1.5, it will zero in on the right answer. So 1.544668. It does say to the nearest thousandth of a foot. Thousandth is 3 decimal places. So we'd want to go with 1.545, because the next number is a 6. So 1.545 feet. If you wanted to verify that, the volume is supposed to be 24 pi. 24 pi is about 75.39822.369. If I use my x value there of 1.545 feet, change these x's to that number, the volume should come out pretty close to this. We did round things, so it's not going to be exact. So, but if I do 8 pi times 1.545 squared plus 4 pi times 1.545 cubed divided by 3, I guess the 4/3 there, hit equals, the answer should be pretty close to that, 75.440, that seems pretty good to me, that they're pretty close. That tells me my answer is probably right. Keep in mind we did round up, this is a little bit bigger than it should be, so that seems like a good answer. On the test, you're going to have a hemispherical, a tank like that, hemispherical sides, cylinder in the middle. Your volume formula is going to be similar to this. I'm going to give you the volume. It's going to have a pi on it, so this pi can go away. Multiplication by 3 makes the fractions go away. The division by 4 may or may not happen. Who knows? But if you notice it, you can do it. If I didn't do that, I'd get the same answer. My calculator's graphing it for me, so even this step here might not be necessary on that problem. Number 10, the number of ways one can select 4 cards from a group of n cards. The order of selection matters, where n is greater than or equal to 4 if given by, or it should be say is given by, p of n equals n to the 4th minus 6n cubed plus 11n squared minus 6n. For a certain card trick, the magician has determined there are exactly 1,680 ways to choose 4 cards from a given group. How many cards are in the group? All right, so we're picking 4 cards out of the group. The group is an unknown number of cards. For example, if I pick 4 cards out of a group of 4 cards, I mean, there might not be very many ways to do that. But if I'm picking 4 cards out of a group of, like, say, 8 or 12 or 15 cards, now there's a lot of different ways to do it. All right. All they're telling you is this is the formula you're going to use. N represents how many cards are in the group. P of n represents how many ways there are to do it. All right, so again, here's an equation. Here's what the variables in the equation represent. And hey, by the way, 1,680 ways. They're telling us what P of n is. Because again, P of n is the number of ways. N is the number of cards. How many cards? We're looking for n. How many ways? P of n equals how many ways. So they're giving us this equation. We know what this is. So 1,680 equals n to the 4th minus 6n cubed plus 11n squared minus 6n. We're trying to solve that equation. Now, keep in mind, n has to be a number bigger than 4, bigger than or equal to 4, because that's what the rules are of n. And there might be some answers less than 4. We don't care about those answers. Basically the same situation as the last problem. I create my equation, set it equal to 0. I'm trying to find out where this thing crosses the x-axis. But keep in mind, n is going to be an integer in this problem, so we can also do it with a table. So if I were to take my calculator and enter this function in as y1, so I'm going to type in x to the 4th. Always use x's because that's what your calculator likes. Again, caret 4, hit to the right to get out of that power level. Minus 6x to the 3rd plus 11x squared minus 6x and then minus 1,680. Make sure you type it in correctly. That's where you're going to mess up if you mess up anywhere here. Now, theoretically, we should be using the possible rational roots theorem, but keep in mind, we're looking for an integer answer. We have some advanced knowledge of the type of answer we're going to get. The answer is supposed to be bigger than 4. So start at 4. Not right. 5, not right. 6, and so on. Just from the numbers on there, it's already there. But notice, once I get to 8, the answer is 0. This function is supposed to equal 0. When x equals 8, the function's value is 0. That just tells me that n equals 8 cards. Last 2 problems aren't terribly difficult to do. It's a matter of understanding what the equations represent. Number 9 required you set the equation up. Number 10, they gave you the equation. So whatever the equation is, set it equal to that. Solve for n. Your calculator is going to do the hard work for you. So the main idea there is understand what the equation represents. Maybe the one on the test isn't going to be about number of ways to pick out cards, but it'll be that type of problem. Here's an equation. Here's what the variables represent. Here's one of the variables. Find the other one. So expect to be that type of problem. It might not be specifically about selecting cards from a group of cards.